We did these for warm-up, so we should be able to tell me what is our first step in solving letter A here. Cody? Yep, we're going to distribute that 3. We're going to distribute that negative as well as the 3. So let's distribute that to the x and to the negative 2. That gives me negative 3x plus 6. Now I should be able to combine like terms here. 2x minus 3x is negative 1x. Then we know we are going to move all of our variables to what side? To the left. So I'm going to move my variable. Anytime I move a variable, it is always through addition or subtraction. Never am I moving it through multiplication or division. So it cancels out over here. I got negative 4x plus 6 is greater than or equal to 4. And now I can just isolate that x using reverse order of operations. So minus 6. I'm running out of room. So negative 4x is greater than or equal to negative 2. Divide both sides of negative 4. What rule do I need to remember here? I switch my sign when dividing or multiplying by a negative number. So my answer here is x is less than or equal to 1/2. And I'm going to graph that. 1/2 goes in the middle. I'm going to pick one number bigger and one number smaller than 1/2. Do I have an open or a closed circle here? Closed circle. And is it going to point to the right or the left? Beautiful. Any questions on that one? Okay, letter B, we're going to do the same thing. I have multiple steps that I can do here to start out with. I see like terms that I can combine. I also see something that I can distribute. And then I'm going to combine like terms one more time. This is 18 minus 2x. Now I can move my variables to the other side. I always move variables using addition or subtraction. 7x minus 3 is less than 18. I add 3 to both sides. Again, I'm running out of room here. 7x is less than 21. Divide both sides by 7. X is less than 3. Plot it. I have an open circle facing left or right. Beautiful. Any questions on these two? Pretty cut and dry. That's what we expect out of the inequalities that we're going to see on our quiz on Monday. All right. We do have 2 special cases, though. Let's talk about what those special cases look like. Number 1, inequalities are always true. When the inequality is true for every possible value of the variable. So no matter what number I plugged in for x, I would get a true statement. We call this all real numbers. If I get a statement that's always true, your answer should be all real numbers. We do have a little symbol that I'll show you as like an abbreviation for all real numbers. The abbreviation for all real numbers is a capital R with a little line, extra line through it. Or you can just write all real numbers. Then, the other special case is that inequalities are never true. When there is no possible value that we could plug in to make the inequality true, we call this no solution. And if we saw something that was never true, our answer would be no solution. There is no symbol for that. Questions there? Okay, so let's look at what this looks like. Oh, hello. I have a negative 3 that I'm going to distribute. This is negative 18x plus 9. I have this 9 that I'm going to distribute. is negative 18x plus 36. Maybe alarm bells start to go off in my head, but maybe I don't see anything quite suspicious quite yet. So I'm going to move my variables all to the left side. I'm going to add this 18x. But look what happens when I add 18x on the left side over there. What's going to happen to it? They equal 0. They cancel out. So it cancels out on this side and it cancels out on this side. So all I'm left with is this statement here. 9 is greater than 36. Is that always true or never true? It's never true. When we have something that is never true, we call that answer no solution. I'm going to show you what the graph of a no solution graph looks like. Just in case you see it, it's blank. Questions on that one? I recommend, even if you see it in this step right here, you're like, oh, I think I know. Solve the entire thing. Cancel out those x's to make sure. If your x's don't end up actually canceling, then we can't say no solution or all real numbers. So just go through the steps to make sure. Okay, letter B. I'm going to simplify. I can combine some like terms here. I can combine this negative 1x and the 7x. 8 plus 6x is greater than or equal to 6x plus 2. I'm going to move my variables all to one side. They cancel on both sides. 6x minus 6x is 0. I have 8 is greater than or equal to 2. Is this always true or never true? Always true or never true? Is 8 greater than or equal to 2? Yes. So this is always true. So our answer here is all real numbers. Questions on that? Oh, let me show you what the graph looks like. If I had a graph of all real numbers, a lot of people will just draw like an arrow pointing both ways on the top, or some people might shade it in. Here, I'll do 2 examples. So some people just might shade in the entire graph. Some people draw an arrow on the top. Either one works for me. Okay, so let's talk about C and D. We're going to go through those together because there's only 2 problems and I think we can manage. So letter C, what do I do first here to simplify? Read. Distribute. 6x minus 10. What can I do on the right side to simplify? Charles? Add the 5x and the x. I'm going to move my variables to the left side. I'm going to do that by subtracting 6x. Hey. Negative 10 is less than or equal to negative 10 is what I am left with. What is my answer? I have 2 options. No solution or all real numbers. Autumn. All real numbers. Negative 10 is less than or equal to negative 10 is a true statement. So my answer is all real numbers. Questions on that one? Okay, one more. Oh, hello. Hey, there's nothing for me to simplify here. Okay? So all I have to do is move my variables to the same side, right? I'm not doing anything crazy. I'm going to subtract 5n from both sides. Hey, that cancels out. I have 9 as less than or equal to negative 1. Is that no solution or all real numbers? No solution. 9 is not less than or equal to negative 1, so no solution. Questions on those 2? Can I remind us really quickly of that one that we saw in our homework from yesterday? Because now that we have these options, I don't want us to be overusing them. Remember that one that was like 8x is less than or equal to 6x? If you see this, I do not want you to go, oh, those two things are not the same. So, or they're not, 8 is not less than or equal to 6. So that must be no solution. But there is still an x in our problem. If there is still an x in our problem, we are not finished with our problem. What do we have to do to this? James? Ooh. I would maybe write this down on your paper as just a little side note, by the way. Okay, I'm still seeing 2x is less than or equal to 0. Can I put no solution yet? What do I still have to do? No solution yet? What's my answer? X is less than or equal to 0 is a valid answer, okay? We are not going to see something like this and panic and say no solution. We are not going to see something like this and panic and say no solution, okay? 0 is an answer. Everybody understand? Fantastic.